It is especially it's a what mathematics. So interpretation is given importance in also physics subject. Okay, in different subject, differentiation helps us to solve numericals. Okay, so what is the meaning of a depreciation? We are going to discuss meaning of a depreciation, some formulas regarding this, and with examples, we will solve a lot of numerical examples. Okay, I will take some examples and then together you and me we will solve. Okay, so with formula we will be solving what numericals. Okay, so what is meaning of differentiation? Look, differentiation it is a saying that a small tiny, even a tiny as much as a tiny, even you can't see by your eyes. Okay, that tiny. So tiny material, to find out tiny material we need differentiation. Okay, we need differentiation. But I said material rather than saying in the context of a differentiation, we would say what slope. The slope what is a new for you. So slope is all about you can say okay. Slope is found in graphs. Okay. So coordinate already you know coordinate in which there are there are four fields: first, second, third, fourth, and we see what x positive and other side x negative. One side is what y positive and one side y negative, like that. We say we are in coordinate. And here, similar here, when we talk about the slope, then with the help of graph, we can deeply understand about slope. Slope, okay. So slope is what? Yeah. So differentiation. Okay. Slope here. This is what coordinate. This x, this y. So it is saying that this is your y-axis and this is your x-axis. But this side will go with the positive side, and this side will go with the negative side. Similar, this side will go with the positive side with the positive side, and this side downward y-axis will go with the negative side. Clear? So this was what little information about the coordinate. So here slope. Slope in simple language, if we say like that, okay, like that. This is slope. What? This is slope. So here we are looking what? First we are going like this, then we are going upward, then we are going downward, then we are going straight. So this is what we are increasing, decreasing. So this is showing what slope, slope of our path. How are we going? Similar here, here you would say that we are here and we need to go till here. We start, okay, we start to go from here. So now gradually we reached till here. So can you find our slope was straight. Okay, straight. Similar here, you easily can find out what our slope is, what decreasing. So our slope is decreasing. This is going downward. That's why we say, rather than saying downwards in language of physics, we say what our slope is negative. To understand, you can say what this slope is what towards. Similar here, from here we start, and then till here we reach. So this is what upward. This slope is going to upward. Similar, by using this here, we can easily understand what if our slope is like this. So we our object is starting from here. Then we would say what like that. Okay, like that. So our object is here. So of course here first we take what x-axis. Then we take y-axis. You already know. So first of all, you can say our x-axis is going like this. Is going downward. Am I right? Downward. Downward. And y-axis is going. So our x-axis this, and y is going downward. So with respect to x, we are here. Then our we come down, uh, uh, downward. Then till here, we come down more downward, more downward. So with respect to x, our slope is decreasing. So why is it why? We are looking at why. Why is decreasing? This why. Why is decreasing with respect to x? So as x will decrease, similar y is whereas y is decreasing. X is here, so x is here. So here x is constant, but gradually x comes till here. So here our x came down. That shows what x is going towards with respect to y. You can say otherwise you can say our y is going downwards with respect to x axis. Clear? So this y is decreasing. That's why we say what our slope is what negative. When y is decreasing, when y is decreasing with respect to x. But similar, if y is increasing with respect to x, then we say what slope is increasing. Slope is positive. Okay. Either slope is not going decreasing, is not going downwards, and or neither slope is going downward nor upward. So it tells us what slope is constant. Slope is constant. Constant. Clear? Like that. This is constant sign, and this is what? This is negative slope. This is negative, and this is positive. Positive sign. This is positive side. How to represent depreciation? Depreciation, depreciation. How to represent it? We represent by function, by function. How to represent it? So we represent it like that. Why? Like that. Clear? So here, remember, our slope, this is slope, is what? Time. Let's take it, okay? This. This is our slope. So here, this is a B. Already you know, and this is a B. And angle will make here. Now P by B is formula of tan tan theta. P by B. So here, this is what? This is x axis. X axis and P. This is going like that. So this is what? Y axis. So here we will write down y. So y by x. Like that we write by understanding. Then we in the starting in beginning, I said what a depreciation, which means a study of calculation of a small tiny material. So here we are talking about in the context of a slope, in the context of a graph. So here we would say what calculation of tiny slope. That's why here we write what delta y by delta x. For more tiny slope, we can write what dy dx. Okay, this is a way to write differentiation starts when we start to differentiate to differentiate. Okay, so y, this is y, this is y, and this is x. So first of all, and dy by dx, how did we write? Because of tan theta. Tan theta formula is what p by b. So p is our this y and p is our x. Okay, got it. Now I think we should take some questions or some formulas. Some formulas. Some formulas. I write. So here we have what y we have y is equals to 1. So we are going to differentiate it. So how to differentiate? Uh, solve we will solve like that. Dy dx. 1. Okay. So here remember always what any number you are taking any number in solving of differentiation, then our number will be constant. But in some places, number will not be constant. If numbers are with multiple, then our numbers will not be constant. Okay. With addition with the differences, only single number we are looking, then we can say what this number is common. Similarly, y is equals to 1. So it is saying that your 1 is a constant. It is not going down, it is not going downward and it is not going upward. Your position of y is at one point. Is at one point. I am telling you as a graph. So it is a fixed. That's why we say constant. Let's suppose we have a 5, y is equals to 5. So we can say what? Our 5 number is at a fixed point. Our slope is not going downwards and also is not going upwards. Instead, our slope is at one point. That's why it is said what? Constant. So of course, this will be 0. Okay. This was compulsory to understand because like that question can come in some numericals, in hard numericals. When we understand clearly one step, then we can solve confidently big problems. Now next, y is equals to x. Now you have to differentiation it. How would you differentiate? You would write like that, like that. Am I right? Okay. I wrote dy mm, upon dx because now we are doing depreciation. That's why. That's why. Okay. So we have to depreciation x. So here x we will write. So always remember depreciation of x is always 1. We are solving formula. After solving the formulas, we will take numbers. We will take numbers. Y is equals to x up x raised to the power n. dy by dx and then x raised to the power n. Then dx. Okay. So here xn. So up alphabet we write downward with the base we write. Exponent we will write first of all with the base. So base is x. So with x we will what exponent. So n then x n then x. So here we wrote 8 with base. So suppose we will reduce 1 from n. From n. This is what just formula to keep remember. That's it. Okay. Towards we are moving. on. Now we have y is equals to 1 by x raised to the power n. It is also simple. Just we can write like that. It is 1 by 1 upon x raised to the power n. Can we write like that? This is a value of this is equal is same as the value of this. Now we can solve. We will be able to solve this. Okay. So dy upon dx here. Exponent we will write with base. Base is x minus n, then x. Okay. Now exponent we will reduce by 1 from 1. So minus n minus 1. That's it. That's it. We have solved. We have solved. Now we are moving on. Next. You have now y is equal to sin x. It is also simple, but we are taking different. We are not taking similar question because it is a beginner. It is a beginner to start the depreciation. So here dy by dx, then d sin x upon dx. So already we know opposite of a sine is what? Cos x. That's it. Okay. Similar. Y is equals to cos x. It is also simple. So like that. Dy by dx. Okay. So we are going to represent to cos x. Cos x. So opposite of a cos x will be what? Minus sin x. Minus sin x. It is rule. We can't change rule. If we change rule, then we can confuse. We can be confused. Got it? Okay. We have done how many? Six questions. But it was almost about two lines. I am going to take next question. Next question is mm, y is equals to a raised to the power x. Uh, so here dy by dx and then A raised to the power x, this will not change. It will remain same. Okay, it won't change. It won't change. A raised to the power x will remain same. Moving on, y is equals to ln x. So dy by dx, dy by dy by dx. Okay, dy by dx. So here dy by dy upon dx. So here formula of depreciation of ln x is 1 by x. 1 by x. So by making process, it will be better for first time to solve it. So formula of ln x is what? 1 by x. That's it. These are formulas of a depreciation because it will help. That's why. Now we are going to take next question. Okay. We have now new thing contains in multiplication and addition and addition. Okay. It is new. What is new? Content so in multiplication and addition. Remember always what if numbers only numbers for example 4 5 6 15 96 so 2.50 like that are in single form, then these types of number will be known as constant. But numbers are with multiplication, multiple, then these numbers will not be constant. That's what we are going to understand in this case. Okay, so let's take a example to understand it. Function fx. Now, carefully here, look here carefully. We have a example. We have an example to understand it. What is it saying? Okay. So A is a number, not a variable. A is a number. Okay. B is a number, not a variable, not alphabet. So here we have to represent whose x because here we are looking at f. So it is an indication changes both side. It changes both side. Okay. Now divide by d. So here a is a number, as I said you, number with multiplication. This is a with multiple of f x. That's why it will remain same. It will not change. It can't be written as a constant because it is not a single form. It is a with it is with the multiplication. Okay, that's why. Now we are looking at b equal. So b is a number, but it is not with multiplication. It is in single form. That's why 1, 2, 3 numbers will be constant. So to represent constant, we add with uh, so differentiation of a constant is what 0. Okay. Now differentiation of x is 1. That's it. That's it. So value of dy by dx is equals to 1. Okay. Second question. Now first question gets. Let's take. We have y is equals to 2 sine x plus 3. Let's solve it together without any hesitation. So dy by dx, okay. 2 is 2 is a multiple with a multiple of sine x. So of course 2 will be 2 will remain same. So here differentiation of sine x will be cos x plus 0. That's it. Yeah. Just we had to put a value of sine x, a value of differentiation of sine x. Next question. Y is equals to 5 ln x plus 2 plus 2. Now, first step is to solve dy by dx. 5 is with the multiplication. That's why we are writing it as it. So, differentiation of ln x is what? 1 by x. 1 by x. So, 5 by x 0. 5 by x. Okay. 5 by x. Now we have numbers in decimal. So how to solve it? How would you solve it? It's very simple. Vertical will come just one step we solved it. Then we will look what can be solved by taking help of first step. Okay. So here number is with a multiple. That's why it will remain same. Okay. Now 1.24 by 3 cos x. So minus sin a minus 1.24 by 3 sin x. That's it. Okay. So shall we move on next question. Y is equals to a into e raised to the power x plus b. Now, how would you solve? You would write like that. A is a number, B is a number, okay? A will remain same. And differentiation of B is 0. Now A and the differentiation of x, A raised to the power x is what? Same. It won't change. That's it. That's it. Next, y is equals to a w cos x plus 0. So here dy by dx. Then a is number. So w is a number. So we are going to represent to cos x. Okay, and already we have 0. So a w will remain same. Cos x, depreciation of cos x minus sin x. Can we write a w sin x? Okay. Now next take okay. We have what pi. Similar dy by dx and 2 is with multiple. 2 is 2 into we are going to represent sin x. Sin x. Okay. 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 Then we have a pi. So value of pi we already know. 3 point like that. 3.2721. So 2 will remain same and sin differentiation of the sin cos x and differentiation of pi will be 0. Now we are getting answer, that is 2 cosec x. Okay. Now we have y is equals to a raised to the power x and a raised to the power x. This is different. dy by dx, then depreciation of, first of all we will do depreciation of e raised to the power x, then e raised to the power 2. Okay, so e raised to the power x will be same, and here e, we don't have e raised to the power x. Instead we have what a raised to the power 2. It is in a number. That's why I already know value of a. I don't know clearly, but we know that a is a value in mathematics. Okay. Now we are moving on the next. We have done what contents in multiplication and addition. Now we are moving on next, that will be some little difference. Let's see what are difference. Next, we have functions in addition and difference. Difference, which means negative sign. Okay. We have question f x then g x. Now, whatever we have, we will do differentiate all. Okay, with the positive side, with the negative side, whatever we have, we will do everything. We will do a differentiation of all. Okay. uh, I show you. Okay. uh, so here, uh, we have to represent of fx. That's why we are changing in differentiation. Then dx by x. Okay. So differentiation of x 1, differentiation of x 1. Yeah. dy by dy upon dx is equals to 2. So first question, y is equals to x square, then add sign, then sin x. Then sin x dy by dx. Okay. So x square. We we have to represent to all whatever we have given in question. So first of all, we will do differentiation of x square. Okay. Then we have add as it we wrote. Then we have after doing the differentiation of x square, we have what sin x. Now we will do differentiation of sin x. Okay. So here exponent we will write with base. This is x. Okay. Now exponent will be reduced by 1. So exponent we have 2. So we are reducing 2 from 1. Okay. Then differentiation of the sin x is cos x. Okay. And here we are looking what subtraction to x then y. Otherwise you also cannot write whatever because 1 is hidden with all numericals. With all numericals. Then we have add cos x. That's it. Next. Next we have what y is equals to x cube plus x square. Okay, let's solve it together. So here we have a simple what it is given. You have y is equals to x cube and x square. Now solve it, and question is saying differentiate it. Okay, so it is in addition. These functions are in addition. So we are going to represent it x cube. First of all, we will do differentiation of x cube. Then we will do a differentiation of x square. Exponent will be written with the base. Then after writing a base, we will reduce exponent whatever we have with 1. 3 minus 1. Then we have a differentiation of x square. So will be 2x. Simple. 3x raised to the power 2 plus 2x. That's it. That's it. Now we have what y is equals to x square plus sine x plus 2. Okay. Uh, we have to do differentiation as well. So first of all, we will do a differentiation of x square, then sin x, then plus 2. Sin x, then 2. Now it is a correct way. It is a correct way to write by making as a process, so that we can check, we can find out any value with confidence. Okay. So 2x, depreciation of x square will be 2x. Then sin x, depreciation of the sin x will be cos x. Then it is a simple number, so constant, which means 0. 2x plus cos x. Answer. This is answer. This is what answer. Now next we have y is equals to x cube plus x square plus l and x. That's the same. Good. So okay, we are going to differentiate. We have x cube, then we have x square, then we have l and x. Okay. So exponent will be written with a base, then exponent will be reduced by 1. Then we have x square. Then depreciation of lx is 1 by x. Got it? Then we have that's, yeah, okay. We have done. This question is unique, maybe for you. 1 upon x square plus 1 upon x cube plus 1. How would you like to solve it? Y is equals to, okay? How? How? Can we write it we have 1 upon x square. Suppose to remove a ratio, we can write in negative. We can write the exponent in a negative because we are removing what? Division. Similar here, exponent will be written in a negative. Here, nothing. Okay, now it is easy. Let's solve it. Dx, then we have 1 minus 2 minus 1. Then minus 3 x minus 3 minus 1. Okay. Then we have 0. Like that. Minus 2x, then minus 3. Then we have minus, okay, minus 3x minus 4. This is answer. This is answer. Now we have next question. Next question is y is equals to 8 and x. Then add, then a raised to the power 8. Then add, cos x. Okay. dy by dx. We already know what differentiation of a and x is how much? 1 by x. 1 by x. Then differentiation of a raised to the power x. Similar, same. We can't change ax. Okay. Then differentiation of cos x minus sin x. Minus sin x. This is our answer of this question. Okay. Can we take next question? Of course, yes. We can take next question. But we have a space. X square plus 4x plus 2 plus 8 and x. Okay. X square. So here representation of x square 2x simple 2x. Then representation of for x only 4. Then 0. Then depreciation of ln x will be 1 by x. 2x plus 4 plus 1 by x. This is answer. This is answer. We don't have a space for solve next question. That's why I am going to erase some space where I have written. I have solved. We were discussing about functions in addition and differences. We have about addition, so we can get subtraction in our question anytime. So we don't need to worry. Whatever we will get, we will solve by help of formulas of a differentiation. I am taking next question. Next is difference. Next we are taking rules of eight functions in multiplications. Multiplications. Product rule. Product rule. We have y u b. So now we will get what questions which will be regarding two functions in multiplication like that. Okay. So here we have to what represent 2u into v. So it says that first of all you will take first first alphabet u. You you have not to do represent of first whatever you have taken. Okay. Second you have to do differentiation. Second is v. So here we will do differentiation of v. Then here we are looking at multiplication. That's why multiplication is said in addition. So here we will give hint of uh, addition. So first of all we had taken what u. Now we taken whatever we had no taken. So we will take B, and now we will represent depreciation of U. That's it. This is not answer. This is a proof. This is proof of a formula. Let's take some examples to solve on the basis of functions in multiplication. So first we have which is y is equals to x into sine. Would you will be would you be able to solve it? This is a formula. This is a rule. Rule is functions is in multiplication. And the formula, this is formula of this. So we have what u. U is x is silence. This is very simple. This is very basic to write in a way. You are the page. Think, do you get some ideas to solve for towards to it? Do you get? Let's solve it together. First of all, we will take what x, but we want do depreciation of x. Only we will put. Now we have put x. Next, whatever we will take. Next, we will do depreciation. Sin x upon dx. Then we have multiplication. That's what we have written. And if we had division, then we write what subtraction. So always remember, it will help very. It will be very useful for you to solve in a numericals, to solve big questions of mathematics. Okay, so in multiple, you will have to write what add. Yeah, was it? Okay. Now we will put what sin x, and we will differentiate of x. Okay. So it is not in form of a differentiation. It is so simple. This is in form of a differentiation. Okay. So differentiation of sin x would be cos x. Then this is not in a differentiation form, so it will be written as it. Then we have x. So differentiation of x would be 1. X cos x, then sin x. This is your answer. Let's take a second question. Second is x square e raised to the power x. So x square into e raised to the power x. Okay. U into v. U is x square and v is e raised to the power x. X square. Okay. So of course we can write direct. First you we will just put, we want to represent of first. Okay. Second we will what do depreciation, and then we would come add. Then we will put second. Next we'll be able to do what the differentiation x square. Oh my god. X square, then differentiation of ax. What we said, you don't want to change, would be same. Then we have add, then we have ex. Ex, it is not in differentiation form. That's why we are not doing it what differentiation. Instead, this is in differentiation form. X square would be written 2x. Okay, x square ax, then ax 2x. Yeah. Okay. Next. Next we have y is equals to sine x cos x. Okay. dy by dx. So here we are looking what functions are in multiplications. Functions are in multiplications. We have two functions. First is sin x, second is cos x. So first will be written as it. We want to write first to do differentiation. Okay. So first will be written as it. Sin x. Okay. Okay. Second would be written to do differentiation. Okay. Then add the second. After add, second would be written as it. Second this second function. Okay. Then first function would be written to do differentiation. To do differentiate. To do differentiate. Sin x is not in form of a differentiation. That's why we are writing it as it. We are not changing it. Then we have cos x, which is in form of a differentiation. That's why we are going to change it by help of a differentiation. So differentiation of a cos x would be sin x, but minus. Then cos x would be written as it because it is not in form of 8. So here sin x, differentiation of a sin x would be cosec x. Now here minus sin x square plus cos x square. Okay, okay. That's it. That's it. These are examples, these are questions to solve. It is saying that you have a functions, but you have more functions. You have not one function. You have two function which is in multiplication. That's why we are looking what it is a different as we were solving in beginning in the starting part. So we have some rules. First, uh, we saw that multiplication multiplication with functions, then then addition, This is a different rule. So numbers are in single form without any functions, then numbers would be written as a constant. Then we saw what addition and differences, functions of addition and differences, which was very interesting. Now we are continuing with functions of multiplication. Functions are in multiplication. Okay. Next question, let's take. Now we have y is equals to x square, then ln x. Solve it. U is x square and p is ln x. So we have two functions. Remember, we have how many functions? Two functions. So functions, we have two functions, but two functions are in multiplication. That's why we will use our formulas for differentiations. Okay, so first functions will be written as it. We won't change x square. And we have put first function. Now second function we would use to do differentiation. Okay. Then we are writing add is a sign because of in our question we have what is functions in multiplication. Okay. Then now we had taken to put what x square. Now we would take to put as it what second function. Second function. What it? Second function is as it, and first function would be taken to use to do differentiation. Got it? X square will not be changed. Can't be changed. Can't be changed. It would be written as it. Yeah. Ln x. 1 by x. 1 by x. Ln x. Can we write it 1 by x? No. Because it is not in form of a differentiation. That's it. So I have decided to write it as it. To write it as it. We have what x square, which is in form of differentiation. So of course we know, yeah, 1x will get cancelled. Now we have x plus l and x, then 2x. 2x. That's it. That's it. Okay. Do we have this next question? No. Now we are moving on next rules. We are going to move on next rules. Next is functions are in division. Functions in division. So here remember we have what function? We have two function. First is u, second is v. So first is upon v. So we have a division. We have a ratio. So in formula we will look what subtraction because of division because we have division. So first of all we are clear that we have two functions. We have how many functions? Two functions. Okay. So let's see formula of it. By solving. By solving. Divided by dx. Okay. So first of all, we will do what denominator by denominator. I don't know. I know, but clearly I don't know. I am in confusion. Okay. U upon V. First of all, we will do what denominator. I think V will do. We will take. Okay. So we are writing it as it. We are not changing it. Second, we would write. Okay. Second. Then subtraction because of it is division. Then U would be written as it. Okay, like that. So this way will be written downward in V a square. That is the formula. What is the just formula? Let's understand it by solving some examples so that we can be clear. We can be clear. So question is y is equals to x square. Y is equals to x square upon sine x. Upon sine x. Okay? Upon sine x. Upon sine x. Upon sine x. Upon sine x. So here we have functions but in division. That's why first of all downward function we will put as it. Okay. Upward function we will write to do depreciation. It is in division. That's why writing. We are giving subtraction here. Now we are going to put uh, upward function which is x square and downward function we would use to do depreciation. Okay, got it? But hold on. But hold on. Here we would write what this downward function, but in square sine x square. Okay, it is not in form of a different differentiation. Okay, sine x. Then we have a differentiation of x square. Would be written as 2x. Then we have subtraction. Then x square. It would be written as it. Uh, then we have what differentiation of sine x. So it would be written cos x. Okay. Then we have sine. Yeah. Sine. 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 I think that's it. That's it. Just we have to put formula by looking functions. Our our way is the way to put a value of functions with the help of formulas is in correct way, then answer our answer would be correct. Okay. If we are putting functions by using formulas of differentiation is in incorrect way, then our answer can come wrong. Okay. Second question I am going to take. Second I have y is equals to x square plus 1 then x. So first we have x square plus 1 then we have x. Okay. So yeah x. Okay. Okay. Then dx. Okay. Then we have square x square. We have x 2x then plus 1. We have a plus 1 which is 0. So 2x only. X square plus 1 1. Of course 2x square minus x square plus 1. This is answer. This is what answer. Next question we have y is equals to sin x plus 1. Let's solve it. Let's solve it. It is in a division form. Dy by dx as you know. First of all, downward function we will write as x plus 1. Upward function will be written to do depreciation. Then sin x will be written as it. Okay, x plus 1 sin x sin x cos x cos x. Then sin x will be similar. We have what? Uh, 1 21 x plus 1 then cos x then sin x. This is answer. Okay, this is answer. Next. Y is equals to sin x upon cos x. So u is equals to sin x, v is equals to cos x. We have a two of functions. First of all, we will put cos x as it. Then we would take upward function to do differentiation. Then we will write subtraction. Then we will write we will put as it what upward function, which is sin x. Then we will take the next downward function to do differentiation. Then upon would be cos x plus y. Am I right? Cos x, cos x. Then d sin x dx, cos x sin x dx cos x. Subtraction. Then sin x. Then cos x upon dx. Then upon cos x square. Got it? Cos x minus sin x minus sin x upon cos x square. So here minus is with multiplication. That's why to write we will write what add, because of this is with multiplication. Cos x square plus sin x square. Then yeah, this is answer. Okay. I thought we have a cos x square plus a sin x square would be 1. Answer would come 1. But no. We had what upon cos x square, x square. That's why. Here, this is our answer. I am going to take next question. Next is chain rule. Next is what? Chain rule. Chain rule is very simple. Chain rule is very simple. Chain rule. What is the meaning of a chain rule in the case of a differentiation? Chain rule. Whatever we would have, but I think it would be in multiplication. Whatever we have, we will do differentiation of all. That is the meaning of a chain rule. But we will what? We will break of all multiplication functions. In multiplication, function would be a lot of functions. That's why it is said chain. I think so. So first question I take, then you guess. Sin x. Okay, okay, okay. Divide by dx. Divide by dx. Okay, okay. So here, first of all, we have sin, then we have x. Okay, it is saying what sin x. That's it, I think. Cos x. It was easy. Yeah. Second question, that's it. Y is equals to sin. This is our question. Now we have two functions in one multiplication function. How would we solve it by making process? Mm, dy by dx. Dy by dx. Sin. First of all, we are taking it as it. As it. Okay. Sin x. As it. Okay, okay, okay. Then we are taking only x square. It is a separate function. That's why. Because of we are in chain rule. Dx square by dx. Okay. Okay, okay, okay. Uh, Sin x is cos x, then x square. 2x. This is also. That's it. How many you have? You have to do differentiation of all whatever you have functions in general in your question. But you should have functions. That's it. And you are in chain rule, so of course it is a 99% chance that your uh, question would be in multiplication. So if your question is multiplication, so of course your functions would be in multiplications. Next we have y is equals to sin 2x. Okay, divided by dx. Divided by dx. So here, first of all we have sin x, then we have 2x, and here it is saying what you have. You have what? Two function. Just you have to identify where is one function, where is the second function. Okay. First of all, we wrote differentiation of sin 2x. Got it? Then we wrote differentiation of 2x only. Cos 2x. Then 2. That's it. This is final answer of this question. So here, first of all, we have done is that first of all we have to do differentiation of sin 2x, then we would differentiation of 2x. So differentiation of sin 2x is what? cos 2x, and then depreciation of 2x is 2. Then we have answer 2 cos 2x. Okay. Next we have y is equals to cos lnx. So first of all, we have cos x, then we have only ln x. That is very simple, but it is in chain rule. Dy by dx. First of all, we have co ln x. Got it? Then we have ln x. So cos x, of course, minus sin x. Then differentiation of ln x is how much? 1 by x. This is answer. I think this is answer. Otherwise, we can write like that. We can write like that. Next, we have y is equals to cos ln x sin 2x. We have done. Next, we have y is equals to 2 sin 3x. So solve. Dy by dx. Okay. Dy by dx. 2 sin 3x. So here we have like that. First of all, 2. 2. Then first of all, 2. Then we have d. Then we have what? D 3x upon x. That's it. Huh. Let me check. Let me check. So here 2x would be what? Let's say we have only 2. Okay. Sine, so cos 3x. So 3x only 3. 0 to the 6 cos 3x. That's it. 6 cos 3x. Next question we have a sine bx. A, then sin Ax, B, okay, x, then I have what, only bx, then I have x. A will be written as it sine, so cos x, then bx. So b is a number, so of course b only, and then a cos bx multiple b. This is answer. This is answer. This